Hello everyone, welcome to this series on how to build your very own Linux distribution absolutely from scratch. And in this video, we're supposed to be setting up Wi-Fi networking. Now for those users who is having troubles with connecting to Wi-Fi on various existing distributions like whatever Linux Mint, Ubuntu, like Arch Linux, whatever distribution, this video also might be helpful for you guys because the underlying principles of how Wi-Fi works is quite similar across different systems. So without further ado, let's actually get started. So I just go to the working directory we ended up with the previous tutorial. And I just probably run the instance of the ISO that we have created previously. And starting from there, I would start explaining the tiny little nitty-gritty details in regards to Wi-Fi. All right, so decompressing Linux kernel, unpacking init, RootFS, trying to connect to local Ethernet network, does it with success. I'm using QEMU now, and yeah, although the real networking device on my laptop is the actual Wi-Fi device, still QEMU sort of emulates the Ethernet. Okay, we got our system booted here. So let's have a look at what's going on at sys, class, and net. Here we have all the available networking devices. Another way to have a look at those to say if config and -a to list all of the devices. Well, eth0 is upwards on the screen, but anyway, it's still there, so you can just say if config and eth0, for instance, and you have only those valuable details in regards to eth0 connection. Now, you might have seen that there is no WLAN 0, which stands for representing the Wi-Fi device. Well, there are a few reasons for this. Well, first of all, I am in the QEMU, and well, although it's sort of possible to have the Wi-Fi device being available under the QEMU, this doesn't mean that you would still have the Wi-Fi device being detected by your system on the real hardware. So now it's time to mention the core parts that are responsible for the Wi-Fi network being actually available on your system. So first and the most essential is that the Linux kernel should be capable of detecting the certain hardware you have on your system. So how to figure out what kind of hardware do you actually have? That's the first question. Once you have the hardware, you then also need the firmware being installed properly. Because kernel, when it boots the module responsible for the certain Wi-Fi hardware, well, essentially that's the Wi-Fi driver. It then looks for the firmware to make sure that everything works properly. And then when these two are available in the system, you would be able to see the WLAN 0 or whatever name for your wireless hardware is. That is going to be available under this list, sys class net. So hopefully that makes sense. Now, the first and the most essential thing to figure out is what is the particular hardware available on your machine. So let me just power off from here because under the QEMU, I will not be capable of answering this question. And there is the command, so you should be sudo. It's called lshw and -c and network. So when you run the command, you see, yeah, it's better to, let me just go to the desktop and let me redirect these, the output of the command to the file called hardware.txt. Let's say Wi-Fi, let's say network hardware. Okay, and now I can open this with the text editor to show you the details, right? So here we have two interfaces. So the Ethernet interface, which we're not interested in because it already works, and this one, wireless interface, which doesn't yet work. So this is the one we're interested in. So the product name RTL 8821CE, and this is the wireless network adapter wireless interface. So this one, so remember this 8821. So you might have a different value here, obviously depending on the vendor of your Wi-Fi adapter. But the idea is, once you have figured out the name of the particular hardware that is responsible for Wi-Fi on your system, you then need to make sure that all the kernel modules are responsible for dealing with this hardware are actually loaded properly. And one more important thing, it's not always the matter of modules. For instance, in the system that we are building, we will not have any modules, and those kind of modules would be embedded into the kernel itself, which is essentially the same from the user perspective, but a bit different from the perspective of the architecture of the distribution. So don't be confused if you don't have the modules responsible for the Wi-Fi, for instance, on your being available on your system, but still you have Wi-Fi working. So this might be happening due to the fact that the Wi-Fi drivers being merged into the kernel itself, not as the modules, but just as the kernel core. So that's another important thing to bear in mind. All right, so another useful command. So once we have figured out this sort of device here, is the following. So we can use the lsmart command, and let's also output this to a file called modules.txt. So lsmart lists all the modules that your kernel uses when it boots. And you remember we had the 8821 CE, but let's just search for the 8821. And you see, like, these are the particular modules, or you can think of them as drivers, that are used by your kernel. So it's not RTL, here it's called RTW, RTW88. So this one CE, also this one. So this is like dependency. Okay, also we have the RT88PCI, and we might have, it doesn't have core, RT88 core, or maybe it does, maybe it's not just printed here. And also my laptop is called Acer, and if you just search for wireless, then you find this Acer wireless. So this is another module that is loaded by the kernel. So now the idea is that if you don't have Wi-Fi working on your certain hardware, this means that this kind of drivers that are specific to your very hardware are not available on the system. So again, you can either use these drivers as modules, or you can have them embedded into the kernel. So this depends on the kernel a lot, and in the system that we are building, we're not going to have any modules, but instead we're going to embed everything into the kernel itself. All right, so just to give you a bit more insight, so for instance, this one, RT888821CE, there is a command called modinfo, and I can say RTW8821CE, and okay, that's just the wrong name. Okay. Let me just see. Okay, underscore there. RTW. Okay. Underscore 8821CE. Yeah, and let's redirect this one to RTW88.txt and have a look. Have a look at this one. RTW.txt. Okay, so this is the file name. So this is where it lives. Kernel driver net wireless. All right, and description: Realtek 802.11 AC wireless driver. So that's how we know that this particular entry under the ls mod command is indeed the wireless driver. So you can, if you are not sure whether the certain entry under the ls mod does represent the wireless interface driver related stuff or not, you can always use this mod info. You can, for instance, do this in a loop to check the description for all the entries being produced by the ls mod, and that's how you know which are actually the modules for your Wi-Fi and which are not. All right, now when we know which particular drivers do we need, we can go to Linux kernel configuration. So I just go to Linux folder back, and yeah, fortunately I've already updated the configuration, but I will also show you how you can update one, like if you've been following the series since the previous videos. But first, let me go to Linux 576, and here it's already compiled. I've already compiled this before making the tutorial. I just want to show you the config file. Config doesn't see the config, and it's a little bit strange. Oh no, this is the new one. Yeah, this is the one that where I'm supposed to be showing you things. So let's cd to Linux. Nope. Linux Wi-Fi. So this one is configured. So here I can say VICI and config. So here I'm searching for RTW88, and here is what has been added since the previous version. So I set the general family of RTW88 to yes, RTW88 core sets to yes, PCI, this is the list of potential particular Wi-Fi hardware devices. I don't quite need these. The only one I need is this one, 88 with 21 CE. It has a couple of debugging functions which might be useful from time to time as well. Now, the biggest question is, how do you know the list of the particular configurations that needs to be enabled in the Linux kernel for your particular hardware? Because again, if you just enable this configurations, this doesn't mean that Wi-Fi device is going to be detected by the kernel in your system, because if you have a different device, you need different driver for it. So this is very specific to the particular device. But I just want to show you the steps that you can walk through in order to figure out which drivers in particular do you want or do you need to install, like configure to yes. You can also configure them to module, but again, assuming the current architecture of the distribution that we're building, I don't really want to have this separated kernel drivers in the root file system. I just want everything to be embedded into the kernel. That's just easier to deal with. And since this is the personal distribution, not the one for like everyone to use, it's really like good to configure everything like for your very own personal needs. And it's just way more convenient to do like this, or at least for me. Anyway, so let's go to, so say we've just downloaded the Linux kernel, say we've just extracted files, and we have this sort of, scenario here. So config is no longer, is not available yet. So VICI config, yeah, it's not available. So here I can say make x86 underscore 64 def config. So the steps are quite similar to those we have been considering when we have been compiling Linux kernel. Right now, we already have the config file. All right, so this is the config file. I made a big video describing like which settings are essential for the kernel to work, so what you should add there. And general approach we've been using, so I've been using the predefined configuration file, and yeah, so just reference that video. But in this video, I want to show you a little bit different thing here. So the problem with this config is that if you try to search for your drivers, the drivers that are essential for your particular device, if I just search for RTW88, it just says like it's not set, but it doesn't have anything apart from this, and that's a bit of an issue. So if you just sort of do like this is just not enough for things to work. Yeah, so this is not enough. So how to see all those available modules or drivers? So there is a way. So if you say make help, okay, and let's say make help, let's call it help.txt, and let's have a look this for the text editor. So local mod config, we need to configure modules, date, disabling modules not loaded, nope. Let's search for mod. Okay, all mod config, yeah, selecting modules when possible. Yeah, so this all mod config is what we actually need. So I go away from here. And again, just beware, because we will now ruin the entire configuration file. So you need to make sure you have a backup. I do have a backup, so I don't afraid doing this. I'm not afraid doing this. So you can say make. What was the? Okay, mods. I forgot. All mod config. Make all mod config, like this. Now the .config file has been updated, and if we just have a look at this, now you see like it has lots of things. Yeah, just before we search for what we're interested in, it has a lot of things, and all the drivers, all the available drivers are now being part of the kernel. It's not exactly being the part of the kernel. They all are available now, but you see this M by the end of every configuration entry. Well, that not all, but mostly, yeah. So this M, so yes, yeses are those the parts of the kernel usually. And M, those are usually treated to be modules for the kernel. But you can also set them to yes if you want, if you do not want to have any modules, but if you want to have just one big kernel containing all the drivers in it. Well, again, that's arguable whether that's the good way to go or not. But anyway, this kind of configuration allows us to search for what we're looking for. And if I say RTW88 again, so here you see, starting from this line, let me just make some. Yeah. So these are the, you see like all M's here, well, apart from these two, but anyway. So these is how I've managed to find the proper modules or drivers for the kernel. So these modules, I just made this M to yes all the way along. So I'll just go into yes, 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 yes. Okay, and you can do this automatically using commands, obviously, yeah. And then I just copy pasted this part to the previous Linux kernel configuration I had, and the one that was working quite nicely. So I only needed to do this make all mod config just to get the names for the particular modules or drivers that are relevant to my specific hardware. So in case if you are doing this for your very own system, so once you have figured out the name of your Wi-Fi adapter device, then you've figured out which kind of driver in particular does it use. Then you do this all mod config to find the available modules or drivers for your particular device. Then you can set all them to yes, then grab this and put this to the configuration file for your kernel that you have been using previously. Again, for those of you who just watches this video, is just watching this video and then say the previous videos, I highly recommend to have a look at the video called Compile Linux Kernel, because that would explain how in particular to come up with a basic configuration that I'm about to be populating with these values, right? So I don't need this really, so just escape. And again, so if I go to Linux Wi-Fi, so this is just the same folder as the previous, but the difference is the configuration. So if I just go to the configuration, so this is the basic configuration I had earlier, but it already has all the drivers specific to my particular hardware. So in your configuration file, you need to figure out those drivers relevant to your hardware and set all of them to yes, and copy paste them from the all module configurations to your backup configuration. So hopefully that makes sense. It might sound a little bit weird, so if you have any misunderstanding of what's going on here, any issues, you just ask those questions in the commentaries, and hopefully I will be capable of explaining that. But again, just watching the entire series from the very first video would be really helpful, just like how to deal properly with this configuration, because this takes an entire 30 minutes video to explain how to properly configure Linux kernel. So see the video Compile Linux Kernel that is about to be explaining all this stuff. So now when I have this driver specific to my Wi-Fi hardware being added to the basic Linux kernel configuration file, I now can recompile the kernel. Yes, it takes time, but it's absolutely essential, because otherwise it's simply not going to work. And after I recompile the kernel, and when I put on the real hardware, what is going to happen? I'm going to see the WLAN 0 interface, which represents the Wi-Fi hardware on my laptop. It might take time. You might need to compile Linux kernel a few times. Like that was the case for me. Yeah, and also just forgot to say that you remember that Acer wireless thing also was disabled, but I've re-enabled this because that's specific to my hardware. So if you have something like this on under your LSmart command output, you might also want to configure this. Say you have the EEPC laptop. So it's yes by default, but anyway. So starting from here, you need to make sure that you added the proper configurations of the drivers to Linux kernel configuration. Then you just compile it, and then you need to replace the existing kernel under the ISO with this newly compiled one. I will now show you how to do this. And then boot on the real hardware, and you need to see the wireless interface. Now I just escape from here. And here, yeah, so I just go to, want to see where is my, ISO. So ls ISO boot. Yeah, so this is the previous BZ image. So we don't want this. And also I just want to quickly check my build ISO stuff. Yeah, I don't deal with kernel here, just back in the root file system. Yeah, great. So I want to say CP and Linux Wi-Fi arc x86 boot, and the file called bz image. I want to copy this to the ISO boot and bz image. Okay, so now the kernel has been updated. So I can build again. So again, for you can now just run this build ISO shell script. So this would update the ISO, and then you can burn this on the USB flash drive. I will show you later how to do this, later in this video, I mean. So it takes time because, yeah, Golang is really like big based. So the ISO, because of having this statical link system, the ISO is really huge, like 94, 95 megabytes. It's quite a big one. So we got the ISO built successfully. Yeah, but we're not supposed to be running this for now. And even if I run this under the QEMU, the output would be the same because there is no real like Wi-Fi emulator under the QEMU that represents my specific hardware anyway. Apart from this, you also need what is known as the firmware. So let's do the following thing. You need to find the firmware for your particular device, wireless device. So how you can do this, you might be wondering. So the way I've been figuring out which firmware in particular is actually needed was the following. So I did boot the system on the real hardware, and by the end of the video, I will show you those steps I've been through, and I'm mentioning now in particular. So I ran the system on the real hardware, and then I ran the command to redirect all the Linux kernel messages to the file. I will also show you that in the real hardware. And there was an error telling me that kernel detected the wireless adapter, but it didn't manage to find the firmware. And he did specify the particular binary file he has been looking for. And the binary file my kernel was looking for was called rtw8821c_fw.bin. So I got this file name from the kernel logs. And then I Googled for this sort of thing, and I found a GitHub repository allowing us to actually compile this sort of a file. So the thing I'm going to be doing now, I will now git clone the repository itself. So https github.com. So again, in your particular case, this might be this would most likely be different because you're having different hardware, hence you will definitely have different firmware. But again, I will show you how exactly to figure out which firmware is needed in your particular case, and that would give you a clue like what to search for on internet. So github.com, username is lwfinger, and repository name rtw88. Okay, so cloning this one. Okay, so cd into the repository. There should be the README file. So README. So yeah, unused Realtek Wi-Fi 5 codes. So the code in this repo is kept up to date with the code in the wireless next repository, I guess. The only difference is the changes, blah, blah, blah. Okay, so essentially, this is what we need. And it's very simple to build. You just type make and you are done. You don't even need to install. You don't need to care about the secure boot and making things sign. Well, at least for me, that's not the case because I have those things being disabled on my system. So let's just compile this. And yes, again, so ls. So just make. It takes time. Okay, we got the file here, right? It should be just under the directory. Yeah, it's not in the bin folder or whatever, it's just in the directory. Yeah, so this is the file, the firmware file that is requested by the kernel. So now we need to put this file into the certain location. So how to do this? It's very simple. So we just go back and we go into the root. And under the root, here we need to create a few directories. So -p to create parent directories, lib, firmware, and rtw88. So that's the path where Linux kernel is looking for the firmware. Okay, and so let's see what is in the lib. Okay, lib firmware. Okay, nothing there. And now here to this path, we need to copy what we have. So let's go upwards. So I want to say cp rtw88 and then the file RTW8821C FWBin. So that's the firmware file. Great. I want to copy this to the root lib firmware and there. And the file name again, RTW8821C FW.bin. Okay, so let's see if it actually works. So list lib firmware. Yeah, seems like it's there. Okay, great. So we can already rebuild the ISO. This should be fairly enough to see the WLAN 0 interface on the system, right? But this is not yet enough to actually connect that. So in order to connect, we need to install a few more utilities here. So I just want to say mkdir and iw. So that's the first utility we're supposed to be installing, and I'm cd to the iw. And here I can say curl -silent, and I want to get this from https://io/archive. So this is the repository for the utility called stat again, but I'm just manually getting things there. Archive, bfrost, and I want to search for IW. Let's have a look. Okay, didn't find anything. Okay, just it's not under the bfrost. It's under the RLSD2. Yeah, and here want to download the one called iw.tar.gz and save it to the file iw.tar.gz. Okay, and now tar -xvf and our file. So we are interested in the bin folder. Yes. Okay, so now we need to copy this IW to the root. So cp and IW and bin and IW, right? Copy to root user bin and IW here. Okay, get done with this. Now let's make another directory for the WPA applicant. cd to WPA applicant. Okay. Now let's search for WPA applicant. Yes. So it's here. So WPA applicant. So the WPA applicant is needed to deal with the WPA Wi-Fi networks, because you need to, apart from just sending the password, you also need to encode it, and this application does it for you. Applicant, yeah, just .tar.gz and just call it wpa.tar.gz. So store into the file and extract the archive xvf wpa. Okay, and now again we're interested with this files under the bin folder. So we can do the following thing now. So I can say cp wpa bin and all the files. I want to copy them to the root user and bin, and Yeah, this should work, hopefully. So let's cd to the root, root user bin, and let's see if WPA supplicants. Yeah, so all day has been added here, and also IW. Yes, great. So now I just rebuild the ISO to make sure that I have the root file system being updated properly, and if everything is okay there, I would then burn this newly updated ISO to the USB flash drive and put on the real hardware and show you all the things there. Okay, so I want to build the ISO now. Great, and now let's try to run it. Obviously, it would not discover the Wi-Fi adapter because, again, this is the QEMU, but on the real hardware it will at this stage of boot. But anyway, I'm interested in seeing whether I have the IW, and I do, and whether I do the WPA family of utilities, and I also do have them. Great. So yeah, now we can burn this to the real USB flash drive. So power off here. And I say sudo fdisk -l. So you see this dev sda1 2 3 4. So this is my USB flash drive. So I'm not going to use petitions. I will just burn things to I will just burn the ISO to dev sda. And that's it. So I can say sudo for that, just make sure, yeah, msmd linux iso. Yeah, so I can say sudo dd. Now the input file is msmd linux iso, and the output file is dev sda, and I want to sync. Hold my breath. Yeah, it takes time because it's around like 95 megabytes or so to be written to the USB flash drive. The reason why the ISO image is so huge while not having lots of things in it, well, that's because of the statically linked system, because like Go programming language contains all the libraries like being embedded into itself. Yeah, BusyBox, what else? So yeah, with the statically linked system, the size of the ISO is going to be really huge by the time of adding new packages, because since it's not using the shared libraries, all the libraries would be compiled into the executable. Yeah, 95 megs. Okay, yeah. And now I'm ready to reboot the computer and show you how the Wi-Fi is going to be detected on the real hardware and how actually to connect to the existing network. Well, okay guys, so this is the moment of truth. So here I have my USB flash drive where I just burned the ISO image, and let's power off the computer, and I'm pressing F12 because I have it being configured to select the proper boot device. So okay, now HDD, USB HDD generic USB storage, that's it. And here is the system. Okay, great. So by default, it would start looking for the network devices. Well, once it decompresses the kernel, yeah, it happens really fast. Yeah, now it's looking for the network devices. It finds the Ethernet, but you see like no Ethernet cable over in here, so it's not connected. But it would also see the WLAN 0 device here. Okay, Yeah, file network device WLAN 0, which is good news, which means that we indeed, in particular, we do have the wireless interface being detected. So I promised you to show how to figure out what kind of firmware do you need, how to know in particular which firmware file is Linux kernel looking for. So there is the command. So let's just cd to home for now. So there is the command called dmessage, and if I say -r and redirect this to file called kernel.txt, this preserves the entire kernel log for me. If I now go to the kernel log and the very first, so I'm looking for 8821, and here, yes. So these two lines represent the loading of the wireless adapter driver. So this is the driver RTW8821CE enabling device. And here the firmware. So it did manage to load the firmware successfully. If it doesn't, say you don't have the firmware file, I'll now show again where the firmware file has been stored, then here, just right after this line, you will have the error with the error code -2, which means in Linux kernel, error code -2 means couldn't find the file. Yeah, so here everything goes smoothly. So again, where it looks for the firmware, so we see the lib, okay, the firmware, then RTW88, and this is the firmware file where kernel, the Linux kernel is actually using to deal with wireless adapters. Now, how do we know in particular that we have that? So, well, the simplest way is to do if config, and WLAN 0 is available down below. It's turned on, it's up, it's not down. That's because the init script turns all the network devices on. So just to give you an idea, if I say VICI init, okay, VICI init, so setup networking. So here loops over all of the devices available under sys class net, and it just turns device on by saying up here, and then tries to get the IP address using the udhcpc, but this only works for the Ethernet. It's not yet going to work for Wi-Fi, because for Wi-Fi you first need to connect to the SSID and then provide the password. So that's another story. We are about to be doing that just right at the moment. So on default, on boot, it can only do the Ethernet connection, but not the Wi-Fi, not the wireless connection. So let's have a look at what is happening under the sys class /net. So you can also find the WLAN 0 interface being available right over in here. Okay, great. Now let's, well, we don't even need to go to home, basically. So IW is now available, right? So if I say IWDEV, it will give me the information in regards to my wireless adapter. So this is what we got here. Now we can, well, I know the name for the SSID, but if we don't know that, just go to home again. I can say IW, WLAN 0 and scan, and I want to redirect the output to, let's say, networks .txt. Okay, takes time, and I say VICI networks.txt, and the one I'm interested is called home 2.4. Just should be found. Yeah, so this is the SSID of the network I'm looking for. All this is real time. Yeah, if I turn off my router, my access point, sorry, yeah, this is going to disappear. So all those available are listed here. And once we have the network, so this is using the WPA encryption for, so which means that the password is not sent as the plain ASCII characters or something to avoid getting stolen, but it's being sent encrypted. So because of that, we actually needed the WPA supplicant utility. So I can do the following thing. I can do WPA, let's just go back to root. So I can say WPA and passphrase. Now here I specify the name of the SSID, which is home 2.4. And also I specify the password for that, which is epic admin 1234. And I want to store this to the file that is called, let's store this under the home directory and call it wifi.config file. Now, if we have a look at the file home and Wi-Fi config, this is just a plain text file that provides the encrypted version of the passkey or passphrase, password that we've provided. So this big key PSK is going to be sent to the access point to actually connect to the Wi-Fi. Now, once we are done with this, we can then say WPA supplicant and -b because I want to run this in the background, -d the driver. I'm using the standard NL 802.11. Then -i interface WLAN 0 and -c the file containing the SSID and the password is stored at home wifi.conf, like this. And it says the successfully initialized WPA supplicant. Now, how to check this? So we don't yet have the IP address. We can't serve the internet yet, but we have just established the connection to the SSID home 2.4. So if I say IW and WLAN 0 and link, it gives me an idea that it actually connected to this certain SSID. So the next step starting from here is to assign the IP address to the WLAN 0 automatically. And what I'm supposed to be using for this is the network shell script, which I already have here. If you don't have one, you would probably need to create one. So just want to give you an idea. So adds network shell. So here, what we have here, this is the callback script called by the udhcpc utility, which is standard to BusyBox. The udhcpc utility creates the IP environmental variable, also the mask and the interface. And it sets up the root if needed, it sets up the IP, and it also tells you that the DHCP configuration for the certain device has been initialized with the following parameters. So hopefully that makes sense. Now if I say udhcpc, and I want to run this in the background, the interface is WLAN 0, and -s stands for the script. I'm using the network shell. And I hold my breath, and if I did everything properly, yes, I just received the IP address of 192.168.1.33, and the mask was encrypted. It's actually 255.255.255, but that's just fancy encrypted to 24. And the router is 192.168.1.1. Okay, so if I now try, say, ping Google DNS server, yeah, so it works, fantastic. But yeah, that's not interesting. So we can use the get utility that I've created to resolve the issue of the lack of the leap NSS_DNS library, which is responsible, which is a part of the glibc library, which is responsible for DNS resolution. But I just created this custom application in Go programming language, which works sort of like CURL. So if I go to example.com, yeah, I have the HTML in response, which is fantastic. And also, yeah, what else can we do? We can install Vim, for instance, from static get repository. So I can say get http and as dot minus dot io slash archive slash bfrost slash x86 underscore 64 architecture. Let's search for Vim. Okay, we got some, and let's use, well, I'll probably want to, yeah, it's okay. So I can just say Vim dash 7.3 dash 1 dot gz, and I want to store this to the home directory, and I call it vim.tar.gz. Now it downloads the file since I've used the redirect here. So I'm going to home. Here I have the vim.tar.gz. Let's make directory for Vim and cd there. And here I can say tar minus xvf to extract from the vim tar.gz. What? Whoa, this is interesting. Okay. Oh, I just used the wrong pass. I just seen this. Okay, so one more time. It's just empty. It's just empty. There is nothing there. So, not 2, but 3. Okay. Yeah, now it takes time because it's actually somebody's there. Okay, now this should work. Minus xvf. I just downloaded something that doesn't exist. That's the reason. And Vim. Get one level up. Yeah, now everything works properly. So cd to the user and cd to the binary. We have the Vim here, so I can say cp Vim and put this to the user bin Vim. And now let's go back to root. Let's clear the screen and I can say Vim. And ta-da! We have Vim being installed here. So thanks for watching. Yeah, please like and subscribe if you have found this tutorial useful. Backspace is not working properly, but useful. So yeah, guys, this is it from my side. Thanks for watching. I really hope you've managed to find some useful bits within this tutorial. I'm sorry for it took a little bit too long, but yeah, I really needed to mention all the tiny little details to make sure that you would actually be capable of configuring everything properly, recompile the kernel, add the firmware, and add all the required utilities like IW and WPA applicant to make sure that you can connect to Wi-Fi smoothly. So yeah, this is it from my side. Thanks for watching, and I'll see you later.